All right. So how is it that this course can help? Hopefully I've convinced you that stats is important. It really has real world implications, how well you do your analyses. And I've convinced you, hopefully, that to some extent the responsibility is yours to make sure that those things are being done properly or interpreted properly. So how is it that this course is going to kind of help you go in that direction of being capable of doing that? So here is the kind of stats model that I've seen a lot in my career of how courses work. So you can kind of start anywhere, but let's start over here with stats. Okay, so stats is hard. It really is. There's a lot of non-intuitive kind of thinking that you have to do, and because it's hard, people like me often think that applied people they're too dumb. They're never going to get it. They're going to be too slow. So what we need to do is we need to really dumb down these courses and make it like, kind of like you just have to follow this formula and plug things into this formula and you're going to get the answer and pass the test. So you end up with a lot of these like honestly pretty low quality stats courses that are focused on applied people. Of course, what does that do? That means that people are not actually understanding the fundamental concepts in the field, and things are going to keep being confusing. You're always going to be kind of at the level of plugging something into a formula and not really understanding why. Of course, then those people who are trained in that way go out into the field, and that becomes the standard of what people expect. And people who are trained in this way don't even know that you could do better than that. So there ends up being these low quantitative standards in the field. People keep applying these like formulas blindly. You submit a paper to like an epidemiology journal, and the reviewers say, "Hey, you didn't follow my favorite formula, so I'm going to reject your paper." I mean, makes no sense at all. No real understanding there. And of course, that means that these people who are now in positions of power in the field look at these low quality courses and say, "That's what I learned, so that's good enough." So it kind of perpetuates the whole cycle. So what we're trying to do here at Berkeley Public Health is to kind of change that. So is stats hard? Yeah, stats is pretty hard. I think it's hard. It's always been hard for me. But I also think it's very rewarding. It's a really fresh way of thinking about kind of like epistemology, like how is it that we can know things about the world? For me, it's the core of the scientific method is statistics. So it's hard, but it's rewarding. So given that, I'm gonna treat you like you have that kind of understanding and expectation about the course, and that you're brilliant, you're curious, you're motivated, and that helps me make this course a state-of-the-art course, which is going to teach you actual concepts in statistics and how to think about them critically. Hopefully you'll find that interesting, challenging, but rewarding, and kind of continue this cycle. So instead of me thinking that you're dumb and I need to dumb it down, I'm trying to think here, no, you're students at Berkeley, right? Similarly, I hope that you go out in the real world with these attitudes, and that you set high standards for good work for other people who are even, if you're just doing applied work, even if you're not really producing research, but you're evaluating research or using it to implement policies. I hope that you're taking those standards with you, doing a lot of critical thinking, collaborating closely with statisticians instead of trying to roll your own thing when people don't really know what to do, and that sets a higher bar of you expecting your colleagues and trainees to have this kind of state-of-the-art training, and not just the plug and chug formulas without really knowing what you're doing. So this is the model that I hope we can get to. So what do I mean by state-of-the-art, critical thinking, all this stuff? This is what I want to emphasize conceptually in the course. One is the power of abstraction. So instead of thinking always super concretely about this situation, that situation, I guess like an example is like if you know how to bake, you can bake an apple tart, you can bake a pear tart. You can bake with peaches. Like it doesn't. You understand at some point that it doesn't really matter what fruit you're using in your pie. It all works kind of the same way. You just have to think about what's the moisture content. You have to think about how hot do I need to make it. This kind of stuff. So you're abstracting away from the actual ingredients and recognizing that thinking about it that way at a kind of higher level lets you solve way more problems than if you're just memorizing a recipe for an apple pie and then memorizing a recipe for a different kind of pie, and you don't actually know how to generalize from that. So to that point, really being able to think critically and knowing, after having learned a couple of recipes, then you're able to figure out what is the pattern here. How do I, if I wanted to change something about this recipe, so I can make it different. Let's say I want to sub in the apples for pears or something like that. What is it that I need to do? What are the other variables that I need to account for? Is there more moisture? Do I need to make it hotter or less hot, whatever? So this kind of critical thinking, instead of always having to reach for a recipe, is super important. This one, being able to define the problem and then solve it. Oftentimes stats, as you probably know, is taught with like a perspective of like, I know how to do a t-test, so everything's going to be a t-test. Or I know how to do linear regression, so everything's going to be linear regression. So I want to kind of flip that on its head. Instead of thinking about what are the tools that I know how to use, what is it that you're trying to do, right? So perhaps again, in the cooking analogy, you have in your head, you've seen the picture on Instagram of like this pie that you're trying to make, or maybe you tasted it yourself. And that's what you're going for, and you need to be thinking about how can I get there? Instead of like, well, I know I've baked stuff at 300 degrees before, so I'm just going to bake it at 300 degrees and like pray it comes out right. So defining the problem, what is it that you're trying to do? First think about that, and then do it. And if the right tool for the job really is linear regression or t-test, great. But usually it's not. So thinking from that perspective, that's state of the art, right? And then the last point is just kind of putting the power in your hands to be able to experiment. I say simulation. So now we have computers. There's really no need to a lot of the time. There's no need to like go look up a paper or see if something works. Check with somebody else to see if they've done it. You can actually just try it out yourself in simulation and see, did it give you the right answer or not. So I guess the baking analogy there would be like, you don't have to go Google like a million recipes. You can just try it, right? You can put it in the oven, see how it comes out. If it sucks, it sucks. Try something different, right? So that's to be able to do that, you need to be able to use these computational tools, understand how to use R, and test whatever kind of analysis plan that you have. Generate fake data. Try it on the fake data where you know what the right answer is. See if you got the right answer. Try it again. And set that whole thing up. So that's what I mean by state-of-the-art thinking. In the past, that was not possible. You couldn't do these kinds of simulations efficiently. You had to kind of do theory or math or try to see abstractly if this will work. And now you can just do it empirically. So hopefully this kind of gives you a different perspective. There's the power of abstraction and critical thinking. There's thinking about what is actually the problem that you have to solve, and then the kind of empirical approach. We'll let you approach a problem from many different angles, and I think that's basically state of the art. So the course is still, however, a work in progress. So if you heard about people who took it last year, it was terrible in a lot of ways. I think in some ways people got stuff out of it, but it was definitely a first draft. There was way too much work. I made it way too abstract. The labs were totally useless in a lot of cases. People were very intimidated and kind of disillusioned. Like, oh, there's so much. Like now I know there's so much to learn, and that kind of scares me. How am I ever going to possibly learn it all? So, I want to say I've changed a lot of things about the course. So hopefully those things are better. That said, there might still be stuff about it that sucks. So talk to me. Tell me what sucks. One of the great things about last year was that people, after like even week 2 or 3, were like, I have no idea what's going on. The structure doesn't make sense. The lecture, the homework assignment, I don't really see how it connects to the lecture. And I love that. I love hearing that kind of feedback. It really helps improve the course. So please, you're always welcome to contact me and tell me what is not making sense to you. There were like concrete changes that were made about these things. I'll talk about them a bit in the syllabus, I think.